This is 23. It's x squared over x squared plus 9. So I would start by making sure that I can't simplify it. You can't factor the denominator. If it was x squared minus 9, I could factor it, but you can't as it is, which means that there's no hole, right? Like from there, I know no holes. And then I would start with my vertical asymptotes. If I set this equal to 0, we just said it. We can't solve this. You can't square root a negative. It would be square root of negative 9, which means there's no vertical asymptotes. And then horizontal asymptotes, we look at the exponents in the top and the bottom. They're the same, so this is the leading coefficient scenario. So y equals 1 over 1, which is 1. To find your intercepts, I would plug 0 in for x, and it would get 0. And then I would set my numerator equal to 0, and it would be 0. So this is a weird graph. This is like one of those scenarios where you would definitely rely upon your graphing utility because all you had was that line, right? When you graph it, you see that kind of curve happen on the bottom. It goes up and it comes up close to the asymptotes, but it doesn't touch it. So as much of that graph as you could draw is fine. I give you a little, like, I think the graphs on the quiz are like little 10 by 10s. So you should get what you need to do. Extend that out. And then if you wanted to find points, like if I went to plug in points onto the right and the left, you could plug in 1, you could plug in 2. You could also use your calculator and that value chart to plug them in so you get specific points. There is actually nothing like this. Like you get at least 2 asymptotes. You're either going to get a vertical and a horizontal, a vertical and a slant, or 2 vertical and a horizontal, something like that. Yeah, it's just weird because there's only the one horizontal asymptote. 27, same thing? Yeah. Okay, all right. So you know where to go from there? Yeah, okay. Any other questions on the graphs? Yeah. 31. Okay, so I start by, this time you can factor the denominator. This would be x minus 4 and x plus 1. Still nothing cancels out, so there's still no holes. If you do vertical asymptotes, set these each equal to 0, and you get x equals 4 and x equals negative 1. Exponents, one in the top is smaller than the one in the bottom, so this is a y equals 0 scenario. And then your zeros or your x intercepts, set this equal to 0, and I would get x equals 0. That's my x intercept. And it would be my y intercept if I plug 0 in. I'd also get 0. So the x intercept and the y intercept are both 0, 0. And then when you graph it, I would start with my vertical asymptotes are at 4. Negative 1, horizontal asymptote at 0. And then the only point I have is 0, 0. So I know this is one of those scenarios. Remember we said that it could cross through your horizontal asymptote. It cannot cross through the vertical, but it can cross the horizontal. So I know there's something happening there where it's crossing through. Usually that means it has like a cubic shape. And then your curves go opposite your arrows on the cubic shape. So if it goes up, right, down, left, then it's usually like that. But this is where your graphing utility comes into play.
So you wouldn't have to plot points, you could just put it on the graph.
You can use the graphing calculator, yeah. So, and if you want, like if it asks for additional points, I did not on your quiz. But let's say it says, let me get the video. Oh, I'm going to change this. I'm going to go to my y equals. I'm going to type it in. 2x divided by x squared minus 3x. Is it plus 4? Minus 4. Minus 4. Okay, and it does that kind of shape that we thought it would do, right? If it was, like, if you wanted to find a specific point, like if I wanted to know how close it's getting on the x, on the left side or the right side, I just go to the calc, so second calc menu, and I do value. And let's say I want to know what's happening like -3. I would just type -3, and it's going to bring me right to -3 and tell me that coordinate point. So if you wanted the points, because you're not sure, you can use them. Especially for the graphing calculator, the one that kind of blended stuff together and gave you like that weird curve and you're not sure what's happening there. That's a great tool. So second calc, go to value and then just type in what the X value is and it will give you the Y value. But for your test, as long as you give me the asymptotes and the intercepts, like all those parts, and then you give me the general shape of your curve, it's fine. So this would obviously have arrows on all these directions, okay? And it's gonna come close to without touching your x-axis there.
I know how to get the middle, but how do you get the two outer ones?
I mean, the graphing utility shows that to me, but if I didn't have a graphing utility, I would plug in points. So when you're setting up, and like that will be like, I know I do it for pre-calc honors next year, you're not gonna have a graphing utility for some of these questions. So if you know it's crossing through in the middle, you're gonna take and plug in the other points. So I make them plug in 1 point from over here. So let's say they plug in 5. And when you plug in 5, I'm just gonna cheat and use the calculator, but you would plug in 5 to your equation and you'd get 1.667. So that's like 1 2/3. That tells me it's here. And that tells me my curve is above the x-axis or above that horizontal asymptote. So I know it's up. Then I would come over to this section over here and I would plug in something to the left of my horizontal asymptote, so I could plug in like -2. And I would plug it into the equation and I would get, again, I'm gonna cheat just because of time, but I would actually plug it into the equation. You'd get -2/3. So I know my coordinate point is down here, and then I know that the graph goes underneath the horizontal asymptote. So when they don't have a point from that area to tell them where it goes, I tell them they have to plug in a point. So you just take whatever those values are and you plug them directly into the equation to get the answers.
But in the test, I can just.
On the quiz, you're gonna have your graphing utility, so you literally can use it to find those points. Yeah, Kiara.
Could you also use 43?
Sure. Is that on this page? 43, yeah. Okay, so this one, this was kind of crazy because it had 4 different parts, right? So you have to factor the top. 2 times -3 is -6. Factors of -6 that sum to -5 are -6 and +1. I would get 2x squared minus 6x, and then +1x minus 3. Factor by grouping here. Take out a 2x, x minus 3, a +1, x minus 3. And I'd get 2x plus 1 and x minus 3 for the numerator. For the denominator, it's also factor by grouping. I take out an x squared and I get x minus 2. I take out a -1, I get x minus 2. And so I get x squared minus 1 and x minus 2. And x squared minus 1 breaks down further to x minus 1, x plus 1. So let me just rewrite it over here so we see it a little bit better. X plus 2, x minus 3, all over x plus 1, x minus 1, and x minus 2. So nothing cancels, right? Which means there's no holes. The vertical asymptotes would come from setting each of these equal to 0. So there's actually 3 vertical asymptotes here. One at x equals 2, one at x equals -1, and one at x equals +1. So -1, +1, +2. The exponent in the top is less than the one in the bottom, so this is a horizontal asymptote, that's y equals 0. And then for my x intercepts, I would set my numerator equal to 0. I get -1/2 and I get +3. And I would write the intercepts as -1/2, 0, and 3, 0. -1/2 is here, 3 is here. And then for the y-intercept, I would plug 0 in. For the x, it's easiest to do that from over here. Plug 0 in for the x, I'd get 0, 0. So -3 over, this would be 0, 0, 0, 2. -1.5 would be the y-intercept that's there. So it's here. So then I think, knowing what I know about the graph in the middle, because it's going up in that, I think there's probably like a cubic shape happening there, which means the outer edges are going to be opposites. One's going to go up, one's going to go down. But what's weird is the in-between. This doesn't happen very often where you get like a space in here. And that's where I would just plug it into the calculator. So I would write this whole thing in the calculator. 2x squared minus 5x minus 3 divided by x to the third minus 2x squared minus x plus 2. So I see that it's down on the left-hand side, so I know my curve does this on the left-hand side. I see that it's that cubic shape in the middle. Did I plot on the wrong side? Hang on, let me go back to that. Wait, this should have been a negative 1.5. This. There. And then because it's normally opposite when there's only 3 sections. One goes down, one goes up and down, one goes up normally. The fact that there's something happening in here makes this a really unique case. And I can barely see it from my graphing utility. So in that case, I would want to zoom out. So zoom out, make sure you see the overall shape. Or just adjust your window because it was right there at the top, right? It's happening there. There's actually a parabola shape at the top there. So now I know there's a parabola up here. And then there's another curve coming through here. Remember, it can pass through the horizontal asymptote, and that's what's happening right there. It's passing through a little bit. If you wanted to get really specific about what's happening in here to see how high that parabola goes, the x value there is 1.5. So I can go second calc, go to value, and do 1.5. And it tells me that it's at 9.6, which is consistent with what they found, right? It was just a bit off of, so this would be all the way up here, kind of. It was just a bit off my screen, which makes sense. Because if that was topped out at 10, I should have just gotten a little teeny tiny bit of it. Yeah, there is a curve happening, whether it's a curve that points down or up, it's parabola shape, whatever, cubic shape. There's a curve that happens in between each pair of asymptotes and on the outsides.
So let's say if we did on the quiz, it'd be wrong.
You won't have 3 asymptotes on the quiz, but yeah, like if you left out a part, you're missing part of your curve.
And are we gonna have like something number 35 on the quiz?
Is this what? 35. 35, I mean, a slant happens, right? I mean, a line happens because there's a hole there. So yeah, you want me to do that one? Yeah. So if you look at this one, 35, you're going to factor it, right? So I'm going to factor top and bottom, not bottom, but just top. And the t minus 1 cancels, which means there's a hole at x equals positive 1, because that's what we canceled out. Remember that everything after this, we focus on the new equation. So my new equation is y equals t plus 1, and that is just a line. So there's no variable in the denominator. There's no curve here. There's no nothing. That's just a line, but there's a hole. Because there's a line, there's no vertical asymptote. There's no horizontal asymptote. There's no nothing else. But to find the hole, we would take and plug back in 1. So 1 plus 1 equals 2. I have a hole at 1, 2. So when I go graph this is no longer a rational function. It's just a line with a hole in it. So I would plot it as though it's a y equals mx plus b equation. I'd start at 1, up 1 and over 1, and I'd draw my line. But then there is a hole at 1, 2. So this is an open dot. Let's see how small I can make it. So there should be a hole there.
Are you guys something down the quiz?
You're definitely going to have a hole. It may not be a line with a hole, but you're definitely going to have a hole.
So, you mean like with a hole that's like, that's not just a line?
Yeah. So open up your quiz review. We'll pick one of those. One says fx equals x squared plus 2x plus 1, and then the denominator x squared minus 5x plus 4. So the first thing I'm going to do is factor both the top and the bottom. This would be x plus 1 and x plus 1. That's hard to see, sorry. X plus 1, x plus 1. And this is x minus 4 and x minus 1. So you can actually cross out the x. I did it wrong. Make this minus 2. So then these are minus. Okay. You can cancel through one of your x minus 1s. So there's a hole there. Then moving forward, I would answer everything from what's left. So what's left is f of x equals x minus 1 over x minus 4. So this is still a rational function. This isn't a line because there's still a variable in the denominator. So then from here, I would find all the other stuff. So I've got a vertical asymptote at x equals 4. I've got a horizontal asymptote at y equals 1 because they're the same exponents. There's no slant asymptote. My whole is at 1, and then I plug it in. 1 minus 1, dang it, that's fine. 1 minus 4, 0 over negative 3. So 1, 0 is my whole, which means the x-intercept is going to be over top, but it's fine. So now when I graph what's left, I want to find the x-intercepts, which set this equal to 0, and I get 1, 0. That's why this is weird, but that's fine. And then y-intercept, I plug 0 in and 0 in, I'd get negative 1 over negative 4, so it's 0, 1/4. Now when I go to graph it, I've got a vertical asymptote at 4, a horizontal asymptote at 1. I have a hole at 1, 0. So that means that this coordinate point there, the curve is passing through it, which tells me it's in that bottom left corner, but it's a hole. So there's going to be an open dot there. And then your y-intercept is at 0, 1/4, which is here, which is consistent with the hole, with the curve happening underneath. So I know from previous knowledge that they have to happen in corners. So it's going to go here and it's going to go here, but then I would use my graphing utility to back it up. So I'm graphing, and it doesn't matter if you graph the original or the simplified one, because your calculator would know the difference to x plus 1. Oh, I'm zoomed in. Hang on. So it matches what we drew. And remember, it's not going to have the hole. So you have to have that hole drawn on your test, on your quiz, and you have to give me the coordinates of the hole on the, yeah. You're welcome. All right, so like I said, do as much of that quiz review as you need to do over the weekend. If you want to take a pause, because we're about to do 5-1. If you want to take a pause on 5-1 until Monday and do that for homework, you can. If you want to get a head start, because you know your weeks are crazy, but your weekend you have a little bit more time, that's fine too. What we're about to do is not on the quiz. Yeah. Okay, so chapter 5, section 1, we're going to break down into 2 days. We're going to do it today and we're going to do it Tuesday. This is exponential functions and their graphs. So it's similar in that there's exponential functions, so there's curves, but these are not rational functions. There's not going to be a variable in the denominator. That's the difference. So an exponential function is a function with a base a, so the big number, in this case going to be a number, is called the base, and then the exponent is going to have a variable in it. That makes it an exponential function. So the exponent has a variable in it. It's just x. It's x plus 1. It's x minus 2. Whatever it is, it's going to have your variable in the exponent. The base is not going to be the variable, okay? The rule on this stuff is that a itself is greater than 0. So if there is a negative on the front, it keeps it on the front. So like this. This can be a negative. It would change the values inside afterwards. But the actual negative, when it's like this, is separate from the exponential function. So if you think about it, we do this first and then we take the negative on the front. You won't see that, like you won't see the negative inside. And it can't be 1. A can't be 1 because then it's not exponential, right? If 1 is raised to 1, the power of 1, or 235, it's still 1. That's a flat line. These have some sort of growth. To graph the exponential functions, we're going to get these curves. So these are 2 separate ones. This is not one and the same. So this is on the left would be f of x equals, and this would be a variable to the first, or to the x power. The characteristics of it, if the base is, if the exponent is a whole number, is that it increases as you move from left to right. So this could be like f of x equals 2 to the x, okay? It's going to increase as you move from left to right. There is actually a horizontal asymptote here at 0. So that curve on the left is going to get as close to 0 without actually touching it as it possibly can. And then it's going to increase as you move to the right. The the y-intercept, if I plug 0 in for x, I'm always going to get 1 on my parent function. This can obviously shift around, but on the parent function, you'll always have a y-intercept of 1. And then whatever you plug in for 1 is obviously going to give you what the base is. So this would be like a 1, 2 in that scenario. If the b, which is the base, is in between 0 and 1, so now we're talking it's a fraction, like 1/2 to the x. Now that reverses. It decreases as you move to the right. The y-intercept is still 1 because anything to the power of 0 is still 1, but this would be 1/2 to the first, which is going to give me 1/2, and now it's decreasing as you move to the right, because the higher exponent on a fraction, the smaller the value. So the domain of these is all real numbers. The range would be fixed because it's never going to go all the way down to negative infinity or all the way up. It's going to be one way or the other. And we will literally just use the t-chart to plot these values. So you won't need a calculator for some of these. Some of these you'll see in a minute that you do. But for most of these, you won't need one. Literally just plot a t-chart. So on WebAssign, the assignment actually gives you a t-chart to fill in. It's going to give you the values that you want to plug in, and you'll just plug in those values, and then you'll make yourself a little t-chart. So we're going to do the same thing. So I'm just going to start with -1, 0, and 1. I'm going to plug them in. So 2 to the -1 is 1/2, or 1/2. 2 to the 0, anything to the 0 power is 1. And 2 to the first is 2. And then we've got our coordinate points, so we know the t-chart. -1 and 1/2, 0 and 1, 1 and 2. So here's what you can't do is make that a line. It looks almost like it could be a line. The slope's not exactly perfect, but it looks like it almost could be a line. You have to know that this is an exponential function, and an exponential function has a horizontal asymptote right there and would create a curve increasing faster once it gets past that 1. If that means you plug in extra points, plug in extra points. If you wanted to see what happened at 2, I would do 2 to the second, which is 4. Now I know my coordinate point is all the way up there. If I wanted to see what happened at -2, I could plug in -2. And I'd get 1/2 squared, or 1/4, and I know it's a little bit lower than the 1/2. So when in doubt, plug in some extra points. But on WebAssign, I'm trying to think of how many points it gives you. It gives you a good amount. You got to plug in the points that they give you. It sets up a little chart. You'll plug in the point, and then it will ask you to enter it in to each individual box. All right, so same thing for 2. Again, we'll just set up a t-chart. So I think it gives you, let me tell you. -2 to 2 is what? -2, -1, 0, 1, 2. And then do what we just did. 3 to the -2 is 1/3 squared, which is 1/9. 3 to the -1 is 1/3.
I found this on the web.
Well, aren't you helpful? Yeah.
What number is always plugging up there?
Say again?
Why for the first one you only do -1?
Oh, because that should be enough, but WebAssign wants you to go all 5, so I'm going to follow what the homework's doing.
Or like, it'll tell you what numbers it wants you to do.
On WebAssign, it literally tells you which ones when you're doing your t-chart. If it doesn't, you can do -1, 0, 1. But if it tells you, like the question that I just looked at, gives you all 5 of those. Yep. 3 to the 0 would be 1. 3 to the first would be 3. And 3 to the second would be 9. And then we plot them. -2, 1/9. -1, 1/3. Not going to be perfect, but as long as it's lower and higher than it should be. 0, 1, 1, 3, 2, 9. Again, horizontal asymptote at 0 still. We'll see what happens in a minute when it's not. And then connect it. To get your curve. Yeah.
How do you know that the horizontal asymptotes
With a parent function, which is what we're starting with so far, it will always be at 0. In a moment, you're going to see what happens when we move it. Yeah, you'll see. Yeah.
Are we
Probably like what, obviously this is not your quiz, but probably not. There will be scenarios in which you have to use a calculator on these, like when you have a base, it's called an E. When you have something like that, yes. But there will also be probably some in which you're not going to use a calculator. Yep.
So our test is gonna calculate.
No. It won't be.
Because our test includes like 4.2, right?
Like yeah, right. So it didn't include 4.2, but it may be the simpler graphs. I mean, we haven't even made that. We're not there yet. But chapter 5 is mixed. Some you need it and some you don't.
Is this this week or next week?
It's next week. Is that a thing? Yeah, next week. Yeah. All right. Skip 3 for now. We'll save that for Tuesday. Okay, but go to 4. Now I have a fraction on the inside, right? So we expect our graph to flip. We're still doing the same thing. We're still plugging in the same values, -2, -1, 0, 1, 2. I'd get 1/2 to the -2. That flips it, makes it 2 squared, and I get 4. I get 1/2 to the -1. That flips it, makes it 2 to the first, which is 2. 1/2 to the 0. Anything to the 0 power is 1. 1/2 to the first, 1/2. And 1/2 to the second, 1/4. Then I go to my graph. -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4. If I had kept going, it's just going to get smaller and smaller and smaller as I go, because there's a horizontal asymptote still at 0. And now my curve it decreases. It falls from the left to the right. I don't think it asked for it, but let's talk about it. So domain we said was what on all of these? All real numbers. I can plug in any value I want for x. What's the range on this function? Close, huh? So is there a stopping point vertically? It can't go past that asymptote, right? You see it gets close to, but it doesn't cross through it. So there's no value for all of these, right? The values would start as close to this as you possibly can and then go up. So it's 0 to positive infinity, but it can't include 0, so it's a bracket. I mean a parentheses, not a bracket, okay? So far, as long as, and that's going to happen with a vertical shift, which you're about to see. That changes with the vertical shift. But so far, that would have been the same for all of them, okay? Yeah.
Wait, how is it a parenthesis?
Because it can't include 0. So 0 itself is not part of my graph. I'll never be able to hit 0. There's no way to raise something to a power to get it to be 0.
Are
Yep.
we gonna have to write domain?
I would assume by test time we'll include these. On the WebAssign, no.
Oh.
Yep. Because you're going to see it change when we get to logs. Like, we're going to start to mess around with stuff like that. All right. Let's do 5, and then we'll save 6 for Monday, too. Or Tuesday, not Monday. Now, what's inside is a fraction again. So x, -2, -1, 0, 1, 2. 1/4 to the -2 flips it to make it 4 squared, which is 16. 1/4 to the -1 flips it, makes it 4 to the first, or 4. 1/4 to the 0, 1. 1/4 to the first, 1/4. And 1/4 to the second, 1/16. -2, 16, all the way up here somewhere. I'm just going to plot it and label it instead of going all the way up to 16. If you go by 2s, it makes it really hard to do 1/4 and 1/16. So I would just plot it and label it. -1, 4, 0, 1, 1, 1/4, 2, 1/16. Shouldn't come back up again here. It doesn't have to be perfect, but And again, there's a horizontal asymptote at 0 until we start to shift these up and down. Domain would be all real numbers. Range would be 0 to positive infinity again. Questions so far? All right, now my exponent is negative. I'm still going to do the same exact thing, but I expect that to change. Because what would happen if I raise to a negative exponent? Becomes a fraction. So you can either move that 2 to become 1/2 and then keep your x positive, or you just plug in points like we've been doing. -2, -1, 0, 1, and 2. And it will happen when you plug them in. So 2 to the -2 becomes 2 to the second, which is 4. 2 to the -1 becomes 2 to the first, which is 2. 2 to the -0 is still 2 to the 0, which is 1. 2 to the -1, 1/2. And 2 to the -2, 1/4. So it made it its fraction. Okay, -2, 4. -1, 2, 0, 1, 1, 1/2, and 1, 1/4, or 2, 1/4. So if you were to compare it, this is the same as the 1/2 to the x graph, because 2 to the negative exponent would make it 2, or 1/2. So those would be the same. Horizontal asymptote still at 0, 0. Still at y equals 0. Domain at all real numbers, and range would still be at 0 to positive infinity. Let's save this one. Save for Tuesday. Still good? Yeah. Okay, so all the transformations we have used on all the other graphs, whether they were parabolas or absolute values or cubic functions, still apply to exponential. When you add or subtract something after the function, so this is not in the exponent, this is separate from it. When you add or subtract, it shifts it up or down. Positive shifts it up, negative shifts it down. This is what moves the horizontal asymptote. If it's originally at 0 and I take and I shift everything up 2, then my horizontal asymptote just shifted up to 2. If it was at 0 originally and I shifted everything down 2, then my horizontal asymptote just shifted down 2, okay? So that's what changes your horizontal asymptote, which changes the range. Yep. No. No. Because these aren't rational functions, so there's no variable in the denominator. Yeah. The horizontal translation happens if it's got an x or plus or minus a number in the exponent. You don't really have to worry too much about translating that, because when you plug in your points, it will move it for you. But just know that's what's happening. That's taking it and shifting it left and right. If it's positive, it shifts it left. If it's negative, it shifts it right, just like normally when it's in the parentheses. If there's a negative on the front, it flips it upside down. So my curve that would normally be going increasing as it moves to the right would flip over the x-axis and fall like that if there was a negative in the exponent. Vertical stretching and shrinking you'll find from your plotting of the points. It's just going to grow faster or it's going to grow slower. Okay, so don't stress too much about the variable or the number that's being multiplied on the base or the exponent. You're going to find those points naturally just from it stretching or shrinking. So stretching means, again, it would be taller, faster, and then shrinking would be shorter. The biggest thing here is, because we're going to plot points on the rest of it, you have to pay attention to your vertical translation, because that's what's going to affect your horizontal asymptote and your range.
So what's that difference with negative bx?
That flips it. Oh, sorry, this flips this one. I should have, let me put it next to it. So the negative on the front, let me put them next to each other. The negative on the front of it flips it over the y-axis like that, like it flips it over. The negative in the exponent flips it over, I just said y-axis. The negative on the front flips it over the x-axis, okay? Like that, like it literally flips it upside down. The negative in the exponent flips it over the x-axis, so instead of going this way, it goes that way. That one you find by plotting points too. Yeah, most of this figure out by plotting points. All right. So now look at the difference between 9 and 10, right? What is the difference between the minus 2 and 9 and 10?
The minus 2 is as a coefficient.
Good. So this is as a constant after the function, and here it's in my exponent. What's the difference on the translation between those? What's the translation for 9? It's down 2. And if it's down 2, it means we shift our horizontal asymptote down 2. For 10, it's what? Right 2. There's no shift in my horizontal asymptote. It would stay at 0. So I'm still going to plug in my points like we were doing before, but when I go to my graph, I'm going to have to pay attention to where that asymptote was. Negative 2, negative 1, 0, 1, 2. So I get 3 to the negative 2 minus 2, 3 to the negative 1 minus 2, 3 to the 0 minus 2, 3 to the first minus 2, and 3 to the second minus 2. This becomes 1/9 minus 2, or negative 1 8/9. You can make it an improper fraction, but when you go to graph it, you're going to have to make it improper anyways. So I would have just changed this to 18/9, subtracted it, and I would have gotten negative 17/9. But then eventually I've got to get it to mixed number anyways. This becomes 1/3 minus 2. So 1/3 less than negative 2 would be negative 1 2/3. This becomes 1 minus 2, which is negative 1. This is 3 minus 2, which is 1. And this is 9 minus 2, which is 7. I'm not even going to plug them in here just because I'm lazy. But on WebAssign, you'll see you're going to plug in boxes. Each of these is going to get an answer, okay? So for negative 2, we're at negative 1 1/9. Negative 2, negative 1, 8/9, sorry. Negative 1 8/9. At negative 1, it's negative 1 2/3. At 0, it's negative 1. At 1, it's 1. And at 2, it's 7. 2, 3, 4, 5, 6, 7. And then we said my vertical asymptote was at 0, 0, and was at y equals 0, but it shifted down 2 places. Did I say vertical? Horizontal. Horizontal asymptote would be y equals negative 2. So use that to help you find the bottom out, like the bottom line of that curve. Now I'm going to get as close to possible as I can to that horizontal asymptote, but without touching it. And then my arrow is going to go up to the right. So if it had asked for it, domain is still negative infinity to positive infinity, but range just shifted down 2, so it's from negative 2 to positive infinity. Questions on that one? So the vertical shift causes the change in my horizontal asymptote. Okay, go to 10. Same thing. Negative 2, negative 1, 0, 1, 2. 3 to the negative 2 minus 2. 3 to the negative 1 minus 2. 3 to the 0 minus 2. 3 to the 1 minus 2. And 3 to the 2 minus 2. 3 to the negative 4th is 1 over 3 times 3 times 3 times 3, which is 81. 3 to the negative 3rd, 1 over 3 times 3 times 3, 1 over 27. 3 to the negative 2, 1 over 3 to the 2nd, which is 1/9. 3 to the negative 1, 1/3. 3 to the 0, 1. Negative 2 and 1/81st is just teeny tiny right above negative 2. It doesn't have to be perfect as long as it's not at 0. 1/27th would be a little bit bigger. 1/3 would be a little bit bigger. Or sorry, 1/9 would be a little bit bigger. 1/3 would be a little bit bigger, and 1 would be there. There's not much of a curve happening here. If you wanted to plug an additional point, you could. If I wanted to add on 3, I would get 3 to the 3 minus 2, and I'd get 3 to the first, which is 3. I at least get a little bit of that curve. You don't need it as long as you know it's going to come back up. Your horizontal asymptote is back to 0 because there's no vertical shift, and my curve is increasing as I move from left to right. Amy. Oh, you're stretching? Or your question? Yeah, okay. So again, the only thing that causes a shift in your horizontal asymptote is your vertical shift if you add or subtract anything after the exponent. Yep.
So do we have to like graph like the line that's shifting or we just like
It will if I like can think back to what I think we will probably have to do on the test, you will probably have to identify your horizontal asymptote, your y-intercept, which is that middle point when you plug in 0, like 1/9, domain, range, graph, and the plugging in of the points. Like I think you might get one big one like that. Yeah. So the like if you fill out your T chart, the X intercept is always going to be, or the Y intercept is always going to be the middle point because it's where 0 is. This would be Y intercept. Domain would be negative infinity to positive infinity. Range 0 to positive infinity. Horizontal asymptote. Y equals 0. And then you'd have your T chart, and then you'd have your graph. Questions? Okay, there's 2 more. We're just gonna do, we're gonna. There's one more, and this one you have to have a calculator for. So this E is called the natural base. It's actually a button on your calculator. You should have a button that says LN, and then above it is E to the X. That's the button we're talking about, okay? E is just like, it's a variable that represents a value. So like pi represents 3.14, blah, 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 but we rounded to 3.14. E represents 2.717172, all the way, and we round it to like E is approximately 2.7. You won't have to round it though, you'll use the calculator one. So you'll use literally the key that says E. So when we set up our T chart and we do -2, -1, 0, 1, and 2, you'll plug in E to the -2 and you'll let the calculator do that work for you. So second ln is where my E to the X is, and I do -2. And I get 0.135. I'm going to round to the nearest tenth. You're never going to get closer than that on a graph. The T chart on WebAssign rounds to 3 decimal places. So it would be 1.35. but you're never going to get, you're not going to get more accurate than 1.1 on when you go to graph it, so don't stress too much about that. Then I would do e to the -1, and I'd get 0.3678, so 0.368. E to the 0 would still be 1 because anything to the 0 power is 1. E to the first is just e, which is that 2.718. And then e to the second is 389. So when we go to graph these, I plot those points. -2 and 0.1 is going to be really teeny tiny. -1 and 0.3 is also going to be tiny. 0, 1, 1, 2.7, and 2, 7, so 3, 4, 5, 6, 7, 7.3. There's no vertical shift here, so there's still a horizontal asymptote at y = 0. And then I just connect my points. So there is like number 8 in the homework, number 9 in the homework, both involve E, and you're going to have to use a calculator to find those values. I'm glad I just checked that because I forgot.